Okay. It's doing its thing now. Good. So I copied the first one. There is positive 1 here. I don't need parentheses. Negative 7x squared plus 4x minus 7. And now, indeed, there is a negative 1 here that needs to be distributed to both terms in parentheses. Can anyone tell us what to write next?
8x minus 2.
A sign first.
Oh, plus.
Very good. Plus 8x minus 2. Do we all agree with plus 8x minus 2? Very good. Now, I have to establish the degree. Why I establish the degree first? So I know how to present it in descending order. What is the degree? 2. So indeed, this is the only one, so the degree is 2, so all I have to do is just copy it. Then I continue with 4x and go along. Oh, there is another one. So 4x plus 8x. 4 apples plus 8 apples. So that is plus 12x. And then negative 7 and negative 2. Yes, please, Whitney. You're talking about... Thank you. I was asleep at the wheel. Sorry about that. I copied, but I copied negative instead of positive. He's right. Sorry about that. So now I'm checking everything. So that's correct, and that's correct. Very good. So now I'm going to ask the leading term, please.
The first one. Negative 7x squared.
Very good. The leading coefficient.
Negative 7.
Very good. Okay, so let's look at one more example and move on to...
I've got one question.
Yes, please.
So the leading coefficient is always the first term after you've organized it?
The leading term is always the first term after you organize it.
Right, but what determines the leading coefficient?
It's the number of the present in front of the leading term.
Okay, so it does involve...
It has to be part of the leading term,
Okay, all right.
and it has to be just anything that has no variables in it. That's the coefficient.
Okay.
If I say x, I really mean 1x. So the coefficient is 1. If I say 15x squared, the coefficient is 15.
Right, and then if the leading term happens to be like x squared or something like that,
Then the leading term is 1.
That's 1. Okay.
Yes.
All right.
Yes. Okay, so let's look at 60. Same page, 3 to 28. Negative a squared plus 1 minus, in parentheses, a squared minus 3 plus, in parentheses, 5a squared minus 6a plus 7. We're adding and subtracting. Ready? First I copy negative a squared plus 1, then minus a squared plus 3 plus 5a squared minus 6a and plus 7. Are you with me on this one? Okay, so then I'm looking for the degree first, and based on that, I start arranging it in descending order and combining like terms at the same time. So the degree of this polynomial will definitely be 2. So then I have this and this and this. 5 apples minus 1 apple and minus another. How many apples are left? 3 apples. Good. Next in line. So these are accounted for. Next in line. The next in line, the next in degree in line will be degree 1. Yes, negative 6a, there is only one. And then no degree.
Plus 11.
Yes. So what type of polynomial is this?
Trinomial.
And what is its degree again?
2,
Leading term?
3, 8, 3,
3a squared.
Leading coefficient?
3.
3.
That's it. Do we need more addition and subtraction of polynomials, or can I move on to multiplication?
Let's move on.
Okay. So you have this work as well. Okay. So this, after you redo the problems we did in class, and then these, so we can move on to multiplying polynomials. Okay, 5.3. We're going to look at multiplying two monomials, which we already did, just another example. Multiplying a monomial times a binomial times a trinomial, and so on and so forth. And binomials together, and polynomials together. Okay, so I'm going to make one up. Negative 3x squared multiplied by 4 y squared, let's say. We're multiplying here two monomials. We've done this before. This is not the first time. An hour and a half ago, we did the same thing. So I multiply the numbers first. What do I get?
12.
And then x squared, y squared. And this is it. Is this a monomial?
Yeah.
What is its degree?
4.
Perfect. Leading coefficient?
-12.
That's it. Okay, so now let's multiply monomial by a binomial. So I'm looking at problem 10 on page 334. 2x multiplied by 6x plus 3. We've done this before, but not after looking at the exponential rules. Now we know the exponential rules, so we know what to do. I'm going to ask you, can I combine 6x plus 3? Are they like terms? Because I like to do that first. No, I cannot. So my only way of simplifying this is removing parentheses by doing what?
Distributing.
Yes, I have to distribute this binomial to these two terms. So now think of multiplying these two like we multiplied these two. It's the same procedure. So I multiply the numbers first, and I get
12x squared.
yes, because I copy the base I copy the base and add the exponents because I'm multiplying them. I'm multiplying x by x. Very good. It's like feet times feet. It's squared feet. Plus.
6x.
So exactly, plus 6x. This is how we multiply a monomial by a binomial. So let's look at something like 14. Same page. 4x multiplied by 5x squared minus 6x minus 10. Coming back to the previous example, what is the degree? 2. Is this polynomial from the previous problem in descending order?
The question again?
Is this polynomial in descending order?
Yes.
Yes.
What is the leading term?
12x squared.
What is the leading coefficient?
12.
Perfect. Very good. Can anyone dictate the next one? This time we are multiplying a monomial. By what type of polynomial is this?
Try.
Yes. So how many terms do I have to have?
3.
Exactly. So now I have to distribute this monomial to 3 different terms. So please dictate.
20x squared.
Careful.
20x.
That would be just right.
So let's discuss this. This is very important. What is the degree of this monomial?
1.
Awesome. What is the degree of this trinomial?
2.
When I multiply degree 1 by degree 2, what degree do I have to get? Right? It's the same thing. Area of the base is degree 2. Height is degree 1. That's how I get the volume to have degree
3.
Good. Minus.
24x squared. Minus 40x.
Is this polynomial in descending order?
Yes.
Are there any missing terms?
Yes.
Which one?
0.
Exactly, the term with degree 0. Leading coefficient.
20.
Leading term.
20x cubed.
Very good. Okay, I think we are ready to move on to binomials times trinomials and binomials times binomials, something like that, yes? Or not yet? Are we still multiplying binomial, by a monomial? Okay, good. So let's look at 24. And now you'll tell me what we multiply. Y minus 10, y plus 11. What are we multiplying now? What is this?
Binomial.
What is this?
Binomial.
Yes, we're multiplying two binomials. Good. Here's how we do it. We start with the first term in the first binomial. There are other ways. It's up to you. I'm suggesting the following. And sometimes I do opposite. So I distribute y to the first term and then y to the second term. Then I distribute negative 10 to the first term and then negative 10 to the last term.
It's like using
FOIL.
this.
Same thing. It's like we did here for each monomial. Yes.
It's like looking for slope. It's like a slope.
No, the slope is a ratio. We don't have a division here yet. So how much is y times y?
Y squared.
Yes. How much is y times 11? 11y. How much is negative 10 times 11? Negative 10 times y. Sorry. That's what I meant.
10y.
Thank you. Sorry about that. And negative 10 times 11. I showed this, but I said that. Very good. Now, what is the degree of this polynomial so that I know where to start and how to arrange it, and then I can identify other things about it.
2.
Yes, it's degree 2, so then I have to start with y squared, which is by itself. Then are these like terms?
Yes.
Yes. So I will say plus
Y.
y indeed. And then
Minus 4y.
that's it. Degree,
2.
2.
leading term,
Y squared.
leading coefficient.
1.
Very
One.
good. 1. Leading coefficient is 1. Any questions?
So when you multiply binomials, you end up with a trinomial.
Awesome. It's a very good. This is what I'm going to torture you very soon with. Yes, this is a minus b times a plus b. A minus b times a minus b. It's a product of two binomials. It will be a trinomial. Same thing here. Yes. We will end up with trinomials in both cases. Yes, it's coming up very soon. Not today. Okay, so let's look at problem 50. We're going to multiply a binomial. I shouldn't have said that. Now you tell me what is the first factor here in this product. The first factor is
32x cubed.
no. I meant to identify what is this first.
Oh.
But you're right.
Binomial.
Yes, it is a binomial. What is the second one?
Trinomial.
Yes, so we are multiplying a binomial by a trinomial. So I have to distribute 4x to 3 terms, then negative 5 to 3 terms. How many terms will I end up with initially? Initially, not after simplifications.
6 of them.
6, very good. Okay, so let's check it out. So yes, you gave me, Corey, you gave me 32, x to the third, correct?
Yeah.
Okay, then the next one.
8x squared.
Do we all agree with 8x squared? And then
Negative 16x.
I'm done with 4x, correct? I finished distributing 4x to the trinomial. Now I have to come back and distribute negative 5. What do I get? Yes?
4
Very good. Yes?
plus, wait, negative
Yes?
10
Yes.
x
Yes.
plus 20.
Very good. Again, I start by identifying the degree, because once I identify the degree, I should be able to arrange it in descending order at the same time, and also combine like terms correctly.
It's 3.
Yes, it is 3. Good. So I have only one term with x to the third. So now I have these. In descending order, the next in line is power 2. And 8 minus 40 is?
Negative 32.
Very good, x squared. Now I'm here. The next in line is degree 1. And that would be?
So, 4, no,
Negative 26.
Negative 26x. And the last one is the free term, plus 20. Good. So you already told me it's degree 3. Can anyone give us the leading term? Yes, leading coefficient. Very good. Okay, so let's look at 70. And that's as far as we need to practice, I think. Once we know this, we can multiply any polynomials. Can anyone tell us what they are?
the first one is a try.
Very good. The first one is a trinomial. Excellent. The second one is?
Also a trinomial.
Yes. So what I have to do is distribute a squared to 3 terms. Then distribute 3a to 3 terms. And then negative 2 to 3 terms. How many terms will I have initially? 9. And I'm hoping that they will collapse into something smaller. But initially I will have 9. Very good. Can anyone dictate?
Would it be 3a to the 4th?
Careful. I multiply numbers first. 1 multiplied by 2 is 2. A squared times a squared is indeed, copy the base. And you said,
4.
that's it. Now I multiply 1 by negative 5, and I get negative 5. And then I copy the base, and the exponent becomes,
2.
yes, no, copy the base and the exponents. I have 2 and 1.
Oh, yeah, we're doing the squared.
Then a squared times negative 1 is negative a squared. I finished distributing a squared to the 3 terms. Now I'm distributing 3a. So plus what? 6a cubed. Minus 15a squared. Awesome. Minus 3a. I finished distributing 3a to the three terms in the second trinomial. Next.
Minus 4 squared.
Very good. Awesome.
Minus 10a.
Careful.
Plus
Plus 10a plus 2. What do I identify next? I need to identify the degree. Okay, what is the degree? So I know where to start. The degree is indeed 4. So this is where I start. It's the only term. I don't see another. So it's 2a to the 4th. Which one is next in line, if it exists? Degree? Yes. I have this and I have this. Plus a cubed. Very good. The next in line is degree? 2. So I have this. I have this. And I have this.
Negative 20a squared.
So negative 20. Very good. A squared. Perfect. Done. The next in line is degree?
1.
Perfect. So I have this and this. Sine. I cannot write 7a. Yes, I have to write something. Yes. So done, and then plus 2. Very good. So we multiplied and we combined like terms. We were able to identify the degree. We arranged it in descending order. And now can I ask you whether is there a missing term from this polynomial?
No.
No. Degree 4 is there, degree 3, 2, 1, and no degree is there. Everything is there. Leading term? Leading term is 2a to the 4th, and the leading coefficient is? Very good. Okay. Since we only have 5 more minutes, I will just want to show you one problem. 62, and that is 7y plus 2. It's not because Corey asked, it's because this is so important. And then I will show you, you are the only class that I don't start with that, because we don't know it yet. But it's a class that I will show you what I give. I will give it to you soon. This is an agreement that I signed with all my students, other than your class, because you don't know this yet. And I say this is a first day agreement, valid forever, no expiration date. Okay? And this is exactly what Corey just asked a minute ago. Okay? So once we know this, I don't want to talk about them ever again. I'm kidding. Of course I will answer questions if you have any. But once we understand these and we get them embedded in our system, you are going to make a leap forward, not a step forward. Okay, so this is what it means. So I'm going to give you a copy of this. Okay, so what does this mean then? It definitely means
7y squared. To the 4th.
Cubed.
we have never seen this. This is not an exponential rule. Be very careful.
Doesn't mean you.
This is a binomial. We don't have exponential rules for binomials. This is 2 terms inside. All we talked about was a factor or many factors, not terms.
So is it like
You cannot apply the exponential rules on this.
so 7y plus 2 plus 7y? No.
Exactly. This is what it means. Do not fall into that trap. Okay? So this is not an exponential rule. If you had something like this, yes, I would have agreed. You would have said 49, y squared, and 4. But this is not what we are talking about.
So you can't use exponential rules on binomials,
Correct?
but you can use them on trinomials.
Never,
Polynomials.
Never. never, never, never.
So what can you use? What can you?
Right
use?
here. That's what we're doing right now.
No, I'm saying like.
If you have,
You
if you,
tell me what I can't use exponential rules on.
Right.
Can
I'll
I
come
use
back.
exponential rules?
yes, what you can use the exponential rule on is, for example, 7y plus 2 squared times 7y plus 2 to the fourth. Yes, I'm using the exponential rule. I'm copying the base, and the power will be
2 plus 4. No.
6.
exactly.
Yeah.
That's how, the only way I can use the exponential rule of a binomial. Here, I have to write them like this. I just learned how to multiply
Wait, is
what,
that only because it's a single one or something?
it's because of the sum. It's a sum of terms. It's a sum of terms. We have not talked about any of this during exponential rules, right? They were all factors. These are not factors. This is a term, and this is another term. Once they're added, they're not factors. So, let's proceed. 7y times 7y.
49. Y squared.
Perfect. 7y times 2.
14y.
2 times 7y.
14y.
2 times 2.
4.
Good. So 49y squared.
4. 28 y squared. Wait.
Plus
28.
4.
When I add an apple to an apple, I don't get an apple squared, right? When I multiply. So, remember what Corey asked. Wait a minute, at some point in time he said, when I square a binomial, do I get a trinomial? Be very careful. Any questions?